Unit 1 is going to be on factoring. The whole unit is on something that most of you have never done before. In my opinion, the first two units, Unit 0 and Unit 1, are the two hardest units of first semester. And so if you have issues, that's one of the reasons why I'm recording the videos, so that you can come back to this later or watch something, pause, slow down, fast forward, and look at stuff again if you need to. But this section, I remember looking at the notes, and I remembered last year not being able to get through the bottom stuff because I did this on a Monday. You guys are lucky this year because it's a block day, and I definitely can get all this in and give you some good examples as we go through each problem. We're going to be dealing with something called polynomials, and it's hard for me to deal with problems if you don't know what the word polynomial means. It's basically anything that has variables, raised to any exponents, multiplication, but no division. Addition and subtraction also work with polynomials. This is a polynomial. When you are given a problem, it doesn't matter how it is formatted, I always want your answers in something called standard form. Standard form is when you give your answer with the highest degree. X squared has to be first, even though that's a 4. I want 4x squared, that's the highest degree first, then your x, then any constants. They should descend, basically. And you move around. So the 4x squared you would put in front, the 8x is the middle, and then the minus 7 at the end. That's something that you will do as you're doing your problems, and all our answers will be somewhat the same. So let's get to our first example that's in our homework, and that is number 3. Number 3 I chose because it's a subtraction problem. It is not a multiplication problem. There's parentheses here. We have this polynomial being subtracted by this polynomial. And when you ever have a subtraction sign in front of parentheses, this is where we can use the word distribute. The reason why we can distribute is because there are plus signs and minus signs in our parentheses. So here we go. Let me click this. If I have a minus sign, I am going to subtract everything that follows. I can think of it like I'm subtracting the 2x squared. I'm subtracting the negative 4x, which makes that a positive 4x. I am subtracting the positive 2, which means minus 2. Everything else stays the same. The 4x squared, the 8x, the minus 7, all stays the same. When you're adding and subtracting, you can only combine like terms. X squareds can only go with other x squareds. When you're putting together 4x squared minus 2x squared, we are not multiplying them. We're saying how many do we have? And so, what is 4x squared minus 2x squared? 2x squared. I'm going to put a little line through it so I know I've done those two things. Notice we only add or subtracted the coefficients. The x squared stayed the same. It's because we're not multiplying them. We're adding or subtracting them together. The next two things that I can put together, I have an 8x together with the 4x. 8x plus 4x is how many x's? 12x. Then I have a minus 7, which is a constant, with this other constant, which is minus 7 minus 2. Negative 7 minus 2 is? And notice my answer is in standard form, and I've put it all together. That's what our answer would be. It's a polynomial in descending order, and we're done with that problem. If it's a plus sign, it doesn't change the sign. You just combine your like terms. You're adding one group to the next. Most students do not have any issues with problems like number 3 because you've kind of done those before. But when we get to problems where we multiply, this is the beginning stage of where confusion may set in. So let's go ahead and get into multiplying. The first thing that I picked 2 examples of a monomial times a binomial. Those are 2 different names for how many terms does each polynomial have. If I look at this is called a binomial because it has a b squared minus 7. It has one term and another term. There are 2 terms there. This is considered a monomial because it's one term multiplying a binomial. Monomial times a binomial. I just say that a lot just so you know what we're dealing with. We're going to use the distributive property based off the area model. So I'm going to do most of my problems over here. I'm going to show you the area model so you know what it looks like. Some of your Advanced Math 8 and Advanced Math 7 teachers might use this sort of model. It's directly relatable. If you want to use this method over here that I am highlighting, feel free to use it. Most of my students will do the work over here, but this is here just to show you how it looks if it was an area model. Okay, so what we do, if I have b and it's multiplying, I cannot put the b squared minus 7 together because they're not like terms. And so since the b is multiplying this, I can multiply the b to the b squared and multiply the b to the minus 7. B times b squared, I have 2 factors and another factor, which makes a total of 3 factors, b to the 3rd power. Positive times a negative is a negative. 7 times b is 7b. We always write numbers, then letters. Highest degree, then the next highest degree. We cannot put them together. So my final answer for number 6 is b to the 3rd minus 7b. Which would be the same if you use the area model where b times b squared is b to the 3rd, because you have 3 factors, and b times negative 7 would be negative 7b. I just want you to see that the area model works the same. You can choose to do it this way, but a reason why I avoid it is because there's just less work to do. This is a shorter way to do it. But I wanted you to see this because I know some of your junior high teachers may use this, and I even know of a teacher down the hall who uses this in Math 3. So just in case you see it again, you can see that it's all related. Let's do the same thing for number 8. Number 8, I have 2k plus 5, and then we're multiplying a 7k, a binomial times a monomial. You can, because there's nothing in between these parentheses, we're multiplying. When we multiply, you can do things front to back or back to front. It's the same thing. It's the same thing as this kind of area model where this 7k is going to multiply the 2k, the 7k is going to multiply the 5. If you ever get stuck, just think about what it looks like when you're doing the area model. 7k times 2k, 7 times 2 is 14. K times k, since you're multiplying, is k squared. That would be the same thing here. 7k times the plus 5, we would be adding 35k. Same thing that it would be there, 35k. There's our area model. Can we put these together? No, they are not like terms, so that's what our answer would be. So far, so good. Any questions? Then moving up, This one, when we start multiplying a binomial times a binomial, this is the area where you gotta get really good at it. And so much so that you're going to be doing it in these kind of problems, you'll be doing it in this kind of problem, you'll be doing it in this kind of problem. You'll even be doing it in the word problem down at the bottom, okay? So this next idea is something that we got to get really good at. And I have three choices, but I want you to know that I use one of these all the time. As we go forward, I will use the FOIL method of the three methods that I'm about to show you. You are welcome to either use the double distributive property, you are welcome to use the FOIL method, you are welcome to use the box method. All three methods work. I'm going to show you how each of them work, and then I'm going to tell you that I just use the FOIL method, and so if you are wondering, use the FOIL. Okay, it's all good. It's up to you. Here it goes. Let's start off. If you think about what we've done before, where we had, let me cover this one up for number 9. If I cover that up, you have an x that's a monomial times a binomial. This times the x, this times the 8. That's the distributive property. That's where you get right there. And since you covered that up and you did this term to both of these, and then you cover this one up, you could do this one to both of these. That's the double distributive property, where you do the first term times both of those, and then the second terms times both of those. If you do that correctly, x squared plus 8x plus, this only multiplies into here, 3x plus 24. Sometimes these two middle terms will combine because they're like terms. And you would get x squared plus 11x plus 24. I am not sure, so I need to take a quick survey. How many of you have heard of the FOIL method? How many of you have heard? There's about 6 of you. Okay, just checking. Just checking. The FOIL method stands for an acronym, I think it is. I think that's what it's called. First, outside, inside, last. The first times the first. Oh, that F is in the wrong spot. It should be right here. The first times the first. The outside times the outside. First, outside, inside times the inside, and the last times the last. FOIL is a way for you to remember which ones to do and when without writing this second step. It's like doing x times x. It's like doing x times the plus 8. Outside, inside, plus 3x. Last is the 3 plus 8 multiplied by each other, and you get the same answer. I will usually use this FOIL method when I'm doing problems with you. And in case you've forgotten, you could always do this as the area model, where you have the x plus 3, and the x plus 8, and they're multiplying each other. You have x times x. There's 2 factors of x. You have an x times 8. There's the plus 8x. I would usually put those plus or minus signs in the problem if I were you. And then the plus 3 and the plus 8 multiplying each other would be a positive 24. And then you're looking for anything that might combine in the area model. and notice all three of these, you get the same exact answer. The reason why I usually use the FOIL method is because I don't write F-O-I-L. I just remember first times the first, outside, inside, last. It kind of reminds me of the 4 different things I need to do when I'm doing a binomial times a binomial. Where students make small mistakes. Let's talk about that. I chose 16 because of the small mistakes students make. 3k minus 8. The quantity of 3k minus 8 squared. What you cannot do here, you cannot, let me even just write that out, cannot distribute the 2. That word is not even correct, distribute. Because so common for students to make a mistake here. This means that there are 2 factors of 3k minus 8. This means that we have a 3k minus 8 multiplied by another 3k minus 8. If you just square the 8 and you just square the 3k, then you're only going to get this corner and this corner of the area model. And you'd be missing these 2 corners, matter of fact. So I always would recommend that there's going to be something like this on a quiz or a test, because I know some of you will miss it. I know some of you will not pay attention to the details. But I also know that those of you in here who pay attention, which most of you do, you're going to know, oh, there's 2 of them. I need to FOIL this. This is one of those trick questions that he told me about. When you get here, you can make a decision. You can either do the double distributive property, or you can FOIL, or you can use the area method. I will do the FOIL method. 3k times 3k. First times the first. 9k squared. Outside, 3k times negative 8. Negative 24k. Inside, negative 8 times 3k is negative 24k. And then negative 8 times negative 8 is a positive 64. Do these 2 terms combine? Yep. Negative 24k minus 24k is negative 48k. And this is in standard form, so we have multiplied it out. It would be the same exact thing, by the way, if you did the area model. Another common mistake I see. Some students think that a negative 24k and a negative 24k cancel out. But when they're the same sign, you add them together and keep the sign. So far, so good. Tried to show you a trick question. I put a little star next to it just so that you'll be ready for the most common mistakes there. And then the problems get a little bit bigger. How do they get bigger? What happens if you have a binomial multiplied by a trinomial? Here's a binomial, 1, 2 objects, multiplied by a trinomial, 1, 2, 3 terms. It's called a trinomial because this polynomial has 3 terms. If the polynomial has 2 terms, it's a binomial, and so on. You can do the distributive property from the x, then do the distributive property from the 3, and that's pretty much what I do. But what I want to show you here is you could use the area model, and in the area model you're going to see you're going to have 6 different things. In the area model, the diagonals are usually what combine together. I want to show you how I use the FOIL method and how I write it out. So I'm going to do this in two different colors. I'm going to start off with red. This times this, this times this, this times this in red. Okay? Let me open this up a little bit so I can make it bigger for you to see. X times x squared is x to the third plus 2x squared plus x. And all I'm doing is pretending the 3 doesn't exist. I'm multiplying by the x, and I'm going, oh, I have the 3 factors. No, I have 2 factors. X times 1 is x. And so I get that red piece right there. And because I ignored the 3, and I did the whole x, the x distributed to all 3 things, I cover up the x, and now what I'm going to do in a different color, I'll do this one in blue. I'm going to distribute that 3 to all 3 terms. Watch where I write the answer though. When I do the 3 times x squared, that's 3x squared, I'm not going to put it over here at the end. I'm going to put it directly underneath my x squared plus 3x squared. I'm going to line up x squareds with x squareds. It's going to save me a step. When I do the 3 times the 2x, 3 multiplied by 2x is 6x. I'm going to write it directly underneath the other variable that has just an x. And lastly, 3 multiplied by 1 is 3. And so what you'll see me do a lot of times is when I do the first one to all 3, and the second one, all 3, I line up the middle terms so that when I add them together, they easily combine. And standard form is really easy when you have x to the third. There's no other x to the third. We can just add these together. 2x squared plus 3x squared, I bet you know what that is. Say it out loud if you know what it is. 5x squared for those of you who said it. I bet you all know what an x plus 6x is. Say it out loud if you know it.
7x.
The 3 is not being combined with anything, so we're just going to put
3.
And that's our answer in standard form. It's a binomial multiplied by a trinomial. There are 6 things, 2 of which will combine. If you're an area model person, it's the exact same thing. The only thing that is different is the diagonals. This diagonal are what you need to look for that combine, and this diagonal are what you need to look for when you're adding them together. If you're one of those type of people. So then we got to go to the next step. Each of these gets progressively more complicated. What happens if you have a binomial multiplied by another binomial multiplied by another binomial? You have to do it in pieces. You have to multiply things left to right. So what I want you to do is I kind of want you to think of the left 2 pieces of number 27 as its own problem. X plus 2 multiplied by the 2x plus 1. We're going to do that and then multiply by x minus 5 later. I'm going to FOIL it. 2x squared plus x plus 4x plus 2. And notice how I kind of line it up right there because I know that this one and this one might combine. Kind of the same thing I do for the trinomials. So 2x squared plus 5x plus 2. And this is still in parentheses. What you should be aware of is that the x minus 5 is still outside, and it's still in parentheses, and it's still multiply. So what a lot of students do is they do these first two and they kind of forget. Oh, some of you might forget about that x minus 5. Make sure it's still in parentheses. Make sure this product is still in parentheses until you now have this kind of problem where you have a binomial times a trinomial. And in this problem, you're going to have those 6 boxes for the area model if you're going to do it that way. So then, we might as well switch back to red and do our first term to all 3. I'm going to write it out, 2x to the third. Since you're all paying attention, why don't you tell me what I get next? The x times 5x is what? For those of you who said 5x squared, you are correct because 5 times 1 is 5. X times x is x squared. X times the 2 is what? Say it out loud.
2x.
Good. That's our first piece. Now I'm going to switch over to blue. This minus 5, think of it as a negative 5, is going to multiply to all 3 as well. Negative 5 times the 2x squared is what? Say it out loud. And I'm going to write that negative 10x squared underneath the x squared. That will save me a step when I'm combining them. Makes my life easier. The negative 5 times the positive 5x is, say it out loud. The negative 5 times the positive 2 is, say it out loud. And so our final answer is where we combine all our like terms together and it's simplified. What does this first term simplify to? Go ahead and say it out loud. 2x cubed. We have 5x squared minus 10x squared makes, say it out loud. 2x minus 25x is, say it out loud. And the negative 10 is? That's a big problem. Look at how much space I used on the note paper. You will need, if you are a person who turns in just answers, it's not going to work this unit. This unit, you got to show me, I should be seeing this kind of stuff when you're turning in your problems. If you want to do that, that's another reason why I hardly use this box method. I can show it to you, but I use this primarily so that I don't have to rewrite so many different things. If I was doing this problem, I would have gotten 2x squared plus x, 4x plus 2, and then you have to take that over here and put 2x squared plus 5x, because you have to put these two things together to get that, and plus 2 right there. And then you'd have to do this times all 3. 2x to the third, 5x squared, 2x. I'm just saying, it feels like it's a lot more work, but it's not too much more work. I just don't prefer it, because then you gotta put those together and those together, and you'll get the same answer. I just like, I don't know. To each his own. The last example I have for you is number 31 in your homework. It says, find an expression for the area of the shaded region. Write your answer in standard form. And what it has is it has this shaded region, and it tells you that the distance along the top is x plus 6, and the distance along the side is x plus 6. And then there's this white square that is x minus 2, and this other side is x minus 2. And so what you need to think of is that there is a big square. You may or may not want to draw this. It's up to you. That looks like this. And we could find its area by doing the base times the height. We could also find the area of the little square. And we can find its area by multiplying the base times the height. But to find the area of the shaded region here, this blue area, we would have to subtract the area of this one minus that area. So what do we got to do? We got to multiply these two things. And let me show you a common mistake. Yes, this is the same thing as that. But can you see that some people are going to want to distribute that 2, and you're not supposed to distribute that little 2. You're supposed to FOIL x plus 6 times an x plus 6, because you can't forget about that 6x and the 6x. I say that because in the O and the I, you're going to have the extra 6x and another 6x. Let me FOIL this. X squared plus 6x plus another 6x plus 36. And if I'm doing that fast, it's because I've been doing this a long time. You will get that fast as well the more that you do. Think of this as the area of this whole outside piece if it were a solid square. Now let's figure out what the area of this white part is. I'm going to use blue for that particular color. X minus 2 times another x minus 2. The way my brain works is I immediately see all 4 pieces. X squared minus 2x minus 2x plus 4, because negative 2 times negative 2 is a positive 4. I know what this area is. It's x squared minus 4x plus 4. And this is where it gets interesting. We've multiplied these two. We've multiplied these two. To find the shaded area, I have to do what with these two things? And which one am I subtracting? The blue one from the red one. So if you're subtracting this quantity, I use that word, that's the mathematical word. If I'm subtracting this quantity, that means that it now turns into one of the first problems I showed you, where we're subtracting all of it. This minus sign is going to distribute into all 3 things. Let me switch back over. Let's finish this problem in green. I haven't done that color today. X squared plus 12x plus 36. I'm going to end up subtracting an x squared. I'm going to end up adding a 4x. I'm going to end up subtracting a 4 from the x squared plus 12x plus 36. Positive x squared minus x squared is 0. 12x plus 4x is what? Say it out loud. 36 minus 4 is what? Say it out loud. Don't forget the plus sign. That way we separate these two things. And those are not like terms, so we cannot put them together. And our final answer is 16x plus 32. Let's end your notes right there.